from one tank to the other, and we're going to transfer the water at the same time. The transfer of the water is going to represent our forward and reverse reaction. If we start out the reaction with only reactants and no products, only the forward reaction can occur. As soon as we've made some product, though, the reverse reaction can start to happen. As the forward and reverse reaction continue with our equal size beakers, eventually we'll reach a point where the water level in the two tanks are equal. At this point, the rate of the forward and the reverse process are equal. In this case, with equal size beakers, the rate constant, which is determined by the size of the beaker, is the same for both the forward and the reverse reaction. So we end up with an equal amount of reactant and product. We now start out with two different size beakers. The large beaker is going to represent a reaction with a large rate constant in the forward direction. The small beaker is going to represent a reaction with a small rate constant in the reverse direction. We'll start the process over again. Initially, only the forward reaction can occur. As soon as we have some product, the reverse reaction can occur. Notice that the two water levels are constant, but the two water levels are not equal. It takes a large amount of product undergoing a slow reaction to balance a small amount of reactant undergoing a fast reaction. The two rates are equal, but you end up with a different amount of reactant and product. In this case, we say the equilibrium lies far towards the product. In Chapter 14, we'll discuss a number of the factors that affect the position of the equilibrium.